Today's guest is Charles Olsen, Executive Director at Sciencey Products, Inc. All right, Charles, thank you for coming on the show.
Yeah, well, thank you for inviting me. I really appreciate it.
Yeah, I mean, your background from, rockets, engineering, rocket science to coatings and, product development. I love that background. So it's going to be fun learning about all the things you've been part of.
Well, it's it's I've been working since I was a little kid. Grandpa would take us out and he would have us be harvesting salal and huckleberry shoots for the landscape crew that he helped work with. And he had us straightening nails because he got a contract with the McCord Air Force Base to tear down an old building. So here we are, 10, 12 years old out there in the construction zone in the Air Force Base, straightening nails with a hammer.
It's
We've been working our whole lives. So,
Yeah, I mean, it's amazing. Like you were just telling that story, like aspects of that story just show up in your career, you know, construction, industrial work sites, science, Air Force or rocket science.
mm,
So it's
yeah.
interesting how those things kind of affect us throughout our lives.
I got a reputation as a kid for putting together fireworks at our annual Labor Day celebration at the ocean, that sort of stuff. So it's been going on for a long time.
Yeah, yeah. But with your education, you started at science. What was the
Oh,
plan?
yeah. Well, I really didn't start in science, Tats.
Really?
To be honest, my motivation was to try to change the world. So all through high school, I was a bit of a rebel, and not an outstanding person, but I was on the magazine, and I had some other stuff going on.
Yeah, yeah.
But
Describe not a rebel. Whatever you're willing to share.
there was hair down to
Yeah,
here,
below the shoulder. Okay. Yeah.
below the shoulder. Yeah, we had the embroidered jeans. We had sort of a disregard for authority figures in high school, and we had 750 in our graduating class. I mean, this was a huge, huge school, and they'd recently consolidated into a much larger building. So
Wow.
it was an interesting and worthwhile experience in high school. But when I got out, I went into a art program at the local community college. Actually, not a community college; it's Olympic College. It's a 2-year college, and with the intention of being able to communicate my ideas, the world would change. Well, I got my associates in art design, did everything from sculpture to painting to watercolor to printmaking, and it turns out nobody's willing to pay me to change the world. So I thought, okay, what's next? Let's go to engineering. So in 1 year, I was able to finish the whole program to get the associate of science in engineering at the Olympic College. And from there, I mean, in between, I was working at the shipyards. I was employed as first a electrical helper in the trades, just basically pulling cable through the fast guided missile frigates that we were building for the Royal Australian Navy, of all things. Um, then I went on to work in the mechanical engineering department while I was getting my associate's degree. And then I joined the Marine Chemist Trainee Association, which made me a safety and health officer, if you will, for the shipyard to ensure that things didn't blow up or people didn't die of asphyxiation and so forth. But once the yeah, well, it was a challenge getting through the chemie degree, especially differential equations. I took it 3 times. Ended up doing a special course with the graduate level mechanical engineering department, designing a computer program to interpret the Coast Guard regulations for AFFF foam spray down systems for the internal holds of cargo ships. So I built a program in Fortran that would calculate the pipe sizing and flow reductions at every turn for a multi-deck cargo hold in a ship that would meet Coast Guard regulations. That
Talk about
it got me
specializing.
in. It got me in. It got me in. It was a 300 level course. I was an undergrad. The professor took pity on me and let me get through. So I eventually got off academic probation and finished my chemistry degree. It was interesting. in the meantime, I became an RA, a resident advisor. So in my last year there, I was a resident advisor in Man Hall in University of Washington. So
There you
you can
go.
imagine I had a lot of balls in the air juggling. That was really something.
Yeah, yeah. So
Uh,
you
yeah,
changed the world, science, and then you went into some science roles.
yeah. And then I worked at the not the shipyards, but this was much smaller scale, but much more sophisticated. Was the what they know now as Morton Thiokol, which was the rocket manufacturer for both the Peacekeeper Trident missiles as well as the space shuttle boosters. So I was intent on working on the shuttle program and not on the nuclear missile program. But these were solid fuel boosters, and these are big machines that convert high pressure into kinetic energy. So you're going from potential energy and pressure to kinetic energy in the exhaust out the nozzle,
Yeah.
and that whole principle is what makes those things fly. Right, you're throwing
Yeah.
gas out the back from high pressure internally.
I
Uh,
always wonder, like, the stakes are so high. Like, if you're doing R&D in an area where, okay, like, you code a wall and it doesn't work out. I mean, the downside isn't that big, but you get it wrong with the rockets. That's very, very bad. I mean, what
yeah.
sort of steps or stages does R&D look like in when it comes to rockets?
Mm, mm. Extremely conservative. Being a man-rated system, we were constantly emphasized to only make incremental changes, and depending on the level of incremental change, you might end up being on what we called a demonstration motor, or you'd have to do a test firing. And these are full-scale test motors that lay on their side and get fired, and then interpret the results afterward. So yeah, it's an example would be when one of the materials used in the insulation is a rubber EPDM that's used as insulation on the steel casing. Um, Zinc oxide is used in that process, in that formulation. Well, the company that made the zinc oxide wanted to move their factory from literally one side of the street to the other for whatever reason. It required 3 full test motors, before they were qualified to supply material for a man-rated system. So it just gives you an idea. I mean, millions and millions of dollars worth of testing required to approve a single change, not of a process, but of simply a manufacturing location. So yeah, very conservative.
For sure. Where'd you go from there?
Well, from there, I mean, the rocket factory I was on the advanced solid rocket motor program. So we were doing the next generation space shuttle when the program got canceled. So the space shuttle program, as you know, is no longer active. And at that time, the contract for the advanced solid rocket motor was canceled. So it became a lot less R&D oriented, a lot less future growth oriented, on a lot more kind of tweaking around the edges and routine stuff. Wasn't very interesting. So I took a job over at Honeywell, and there was again doing R&D business development. Had the opportunity to take a course with Stevens Institute. I got my MBA, and worked on developing new sealant materials, um, similar to the Kanakafuchi material, MS polymer. You might have heard of it. It's a silane capped polyether. Oh, there we go. Silane capped polyether. Okay. And what we were doing was taking a thiol, right? Specifically mercaptos, and capping polyethers with oxime silanes in an attempt to get around a patent.
Around a patent, you said? You're just trying to get around a patent,
We were
something.
trying to get around a patent. Yeah. Well, I mean, I didn't necessarily completely agree with the approach, mainly because the mercaptos that we were using were never 100% pure. And I don't know if you know about methyl mercaptan, but the stuff that makes skunks stink so badly, well, it's always an impurity in any of these thiol compounds you're working with. So we would always kind of get immune to it when we're working with these materials. But when I'd come home, my wife would go, God, you stink. Because I smell like a damn skunk. And you couldn't smell it because the mercaptos tend to numb out the
Yeah.
nose.
Yeah, sometimes the innovation side is, related to, just trying to find a different, maybe a cheaper way to do something that's already happening.
Oh, right, right. In this case, it was such a popular product that the management felt that they would benefit by having something comparable to it. So it wasn't granted. And again, Dow Corning beckoned, and so I took a position with Dow Corning in their R&D group again. Um, Len Petroff, I can't give him enough props. He was the um, section manager over the R&D group there, and a wonderful teacher. So we learned everything. All of us young guys learned everything about silicon chemistry from him. So you name it, hydrosilylation, reequilibration, Grignard reactions. We had great fun with it. Um,
How close, in a big company like that, how close are you to the customer? Or is it just just like a brief that's handed down through management? How is the direction of the innovation set?
that's a good question, Tats. Once I'd cut my teeth on the chemistry side of things, I moved into a global marketing position for the fluorosilicones. And yes, you were in the customer all the time. You're really trying to understand what their needs are, what sort of technical problem, and whether there's resource and bandwidth to be able to solve that for them. It was really the strong point of the Dow Corning organization that as a marketing manager, you were able to direct R&D resources into projects specifically to benefit customers. So it was definitely a key. One of the key accomplishments there was developing the first liquid fluorosilicone product offering um, for Dow Corning. That was a great project. Big team, 2 years development, and now there's a commercial fluorosilicone
There you
liquid.
go.
Yeah.
So when there's, let's say there's multiple things that look viable, right? You talk to your customer, you see a few different directions where it can go. What are some of the main things that drive it in one direction or the other? Like, is it
Mm,
the market size? Is it, like the company's core capabilities? Like what sort of things set a sway, or is it just individuals that have influence in how things go?
mm. Politics is never one of my strong points. So, I mean, I much prefer to solve an engineering problem than worry about whose boots to lick or whatever, right? But yes, strong personalities, as you mentioned, do have a role to play in some of these decision-making processes. Dow Corning tried to codify this. I think they kind of went overkill. They had a 300 line item spreadsheet where you were supposed to put like a 1, 3, or 9 in terms of all the various, market size, addressable market size, ROI, resource, and on and on and on and on. 300 line items. Okay, to try to figure out whether or not this got a go or a no go in terms of the project. But what it really boiled down to, Tats, and I think as you pointed out, is that if there was a personality involved that had a strong opinion about it and carried a little bit of sway, you could probably get the project approved. And again, how big is the customer and how important are they? Will they be important in the future? Are they growing? Are they shrinking? Are they opening a new market, or are they trying to maintain a market they're losing? All those questions come into play when you decide whether or not to proceed with resources, scarce resources to drive a project forward.
What I'm always curious about are projects that, hey, going through product development,
Mhm.
you think, hey, this is going to work, and it doesn't. And then
Yeah.
there's those projects that, hey, isn't going to work, and it works. But do you have examples of those?
Oh my goodness. Let's see. Well, the one that was kind of disappointing, actually, a little bit, was the Cat 5 cable. So for well, actually, it was a tragedy over in Europe wherein a fire occurred. I believe it was at an airport, and all of the cable plenums carried thousands of miles of these PVC insulated communications cables, and the fire ripped through these cable tunnels and created such a lot of toxic smoke that people died and were injured from smoke inhalation and not from the fire itself. There really was no flame, it was all toxic smoke. So a big push went on to get a non-toxic Cat 5 insulation that would survive, and not produce toxic gases. So a ceramifiable silicone was developed. And we took it a couple different places. We actually created a project that looked at using it as opposed to sculpting the polymer clays and getting rid of the phthalates in the polymer clays. You could put this stuff, you could put it in the oven and bake it. It would come out rock hard. It literally ceramified. Well, it also did that in the Steiner tunnel test, which is a huge, full scale cable tunnel with massive flames coming through it to determine what happens to the cables when they're exposed to these environments. And indeed, we successfully passed the tests. The interest, however, at the end of the project was a lot less than what it started out as. And people realized that the cost, the manufacturing cost, and so forth, that these types of cables would not fly. So there was a little disconnect between what the outrage and the concern of the tragedy was and the economic realities of building a new building, building a new facility. Very interesting stuff, though, and still out there. Those formulations are still out there.
For sure. And how about one that on the surface didn't look like it was gonna go somewhere and took off?
Let's see. Now that's a tougher one. Uh, Probably the PEX projects. In these ones, what you're doing is you're taking medium. They call it medium voltage. It's tens of thousands of volts, but it's medium voltage to the industry of cable manufacturing. And they cross-link the polyethylene insulation using a specific process. There's a couple different processes that can be used, but this one involves a vinyl silane, a peroxide, a catalyst, and an inhibitor. And you put this cocktail, as we call it, together. You inject that into your extrusion line while you're coating the metal cable, right? It's a crosshead feed. And subsequently, after the extrusion process, this stuff, the peroxide reacts the vinyl onto the polyethylene, right, abstracting the hydrogen. The silane then reacts with moisture to cross-link the system very lightly, but enough. So the test is to take a dog bone after curing, put a weight on it, put it in an oven, and then put a weight and see how far it goes. And if it isn't cross-linked, it'll go right to the, fall apart, drip. If it's cross-linked as it should be, then it'll stop. And there's a specific limit that it has to hit. We weren't sure that this would work, but we did spend a lot of hours in a lab doing subscale testing and to see if we can get those things dialed in properly. And lo and behold, it's now a multi-million-dollar business for the company. I mean, they loved it. It undercut the competition, and it was rolled out to 3 other companies that do the similar process.
Wow, very cool.
Yeah, it was like, what the heck? Yeah,
Well, that's what keeps it fun, right? Now
that's
you've
what
done
keeps
this yeah, you've done this for big companies, but also smaller organizations. I mean, what is the difference you find? I mean, obviously resources, but specifically, trying to get innovation going and successful in a smaller organization that may not have the same amount of resources like a Dow or a Honeywell.
mm-hmm. Yeah, that's a good question, Tats. I'm kind of torn in between. Yes, you do have tremendous resources available at a big corporation. On the other hand, the holders of those resources are sometimes very reluctant to give them up, to let you expend them on some project. So again, that's where the politics comes in big time, because you have multiple power centers within the organization, and you have to deal with all that. Um, but again, you have tremendous resources. When I worked at one of the smaller companies, AB Specialty Silicones, excuse me, we were able to engage in projects where it was just, me and 2 other folks that were trying to make that decision. And it was more like, well, yeah, okay. Not quite as rigorous as the other, but with the same intent to get the ROI, to see the resources allocated. And yeah, we had, well, the one project I just described was one of those. It was sort of a ad hoc, off the cuff. When the customer started to show interest and the profitability looked good, it became a full scale project. 6 months later, we had a product, and out the door it goes. We saw something similar when I developed the rubber business for AB Specialty Silicones. High consistency silicone rubber is a block of material that you typically extrusion or compression mold, right? So it's peroxide cured traditionally. And you build this by buying fumed silica, buying gum, buying the treating agents, and putting them into a massive heated vacuum capable mixer. So it's quite a process, and there's a lot of process steps involved. But we contracted with a company that had the big mixers. We put it together. We built a 40 and a 70 durometer, which are the industry standards for your compounding, and that is a that is a growing business right now for them. It's been 6 or 7 years now, and I think it's one of their major revenue streams right now in the company. So I feel really good about that. That was kind of interesting, and it did. It took a lot of convincing. The ROI, we were buying the rubber and selling it, reselling it. And of course, the margin isn't really there. But when you can make your own, now you have the margin necessary. So very interesting project.
There you go. So, if someone is listening to this and they're earlier in their career and they have this "I want to change the
Change the world.
world" kind of mindset, what advice do you have for them?
Well, you'll see my tagline is science in service of society. Okay, okay, I won't be able to make massive changes in the world, but I can make it better. I can make it better in the projects that I work on. So I choose projects that are going to improve things. I'm working on a sustainability project right now with a professor. He's got a patent on recycling fillers out of cured silicone rubber. Why would you want to do that? These things are dirt cheap. You put fillers in to make them cheaper, right? It's $3.50 a pound for this stuff. Why would you want the fillers? They're only $1 a pound. Well, the folks that make thermal interface materials and electromagnetic control gaskets use very expensive fillers, and they are interested in recovering these fillers and reusing them. So, as opposed to taking a silver plated graphite and melting it down for the silver metal value, you can now take this expensive filler, recover it, and then reuse that in a new formulation. So, that is definitely an interesting project. Um, some of the other ones, like working with a small company, I ran into this very recently. One of the folks I'm consulting for is a manufacturer of silicones. And the guy, I mean, he said basically, Charles, stop bringing me new opportunities. I haven't got the number of people I need, and I'm going to be hiring more. So stay tuned. We'll be back in touch here. But keep those opportunities coming. So, but don't expect us to do anything with them until we get more depth within our chemistry department. So those things do happen when you have very small companies that are struggling to properly allocate resources. Yeah.
Yeah, for sure. Awesome. I love it. Well, I like the idea of trying to do our part. I think maybe not one person can, change the world, but if there's a bunch of people that are trying to do it, it could be a nice compound effect, right?
Yeah, and like you say, if you're an early career professional, then yeah, just stay curious. I mean, like I said, I've done everything from the shipyard industry to automotive, personal care, rubber manufacturing, plastic additives. Actually spent some time on the line at Dow Corning adding gum rubber, silicone rubber into thermoplastics on an extrusion line to improve throughput and processing properties, stuff like that. So really don't hold yourself back in terms of exploring things that maybe not what you were educated for, or even that you may not have a real inclination for, but you know open yourself up to those things. Yeah, I think you'll find it rewarding.